Ladies and gentlemen, buckle up your seatbelts. What is that? You don't have seatbelts? Or just lay back and good luck. My name is Professor Sharad, but you can all call me for today, Professor Sharad. As students, we should all know some basic knowledge of mechanical engineering, no matter which class, faculty, department you're in, because it's useful. Today, I'm going to talk about some of the basic concepts of mechanical engineering. I'm going to go over the first law, the third law, stresses, and gears. So to begin with, the first law. The first law of motion states that any object which is at rest remains at rest, but any object which is in motion continues to stay in motion unless otherwise it's stopped by an external force. To illustrate this, let me give you an example of a chicken. Let's say someone were to ask you, why did the chicken cross the road? Now you can use this first law to answer that question very effectively and confidently. A chicken at rest remains at rest, but a chicken in motion has a tendency to cross the road, according to the first law of motion. Moving on. Second, stress. Stress is defined as a force per unit area. To illustrate this, it's best attempted close to exam time. I went to DC close to exam time and asked the person's weight. Force is nothing but mass times gravity, which is weight. And I take a step back and I calculate the approximate cross-sectional area. Now, I calculate their stresses they're going through. Stress is force divided by area. And I tell it to them. And they find it very stress-relieving. This leads to my third point, gears. You know what really grinds my gears? It's a TV show, Jersey Shore. They teach you how to have awesome tan and how to have very good romances, which I've been longing for a very long time. I started talking to them. And also how to make long-term relationships and how to generally be successful in life. Sometimes I wonder why I teach mechanical engineering basic concepts to students. So this leads to my last point, the third law of motion. Newton's third law of motion states that every action has equal and opposite reaction. To illustrate this point, let's say someone in this room, let's say Andrew, were to poke me. Now that's action. When he pokes me, I get really, really angry. That's reaction. So I just illustrated the third law of motion. So in summary, I talked about the few laws of motion, stresses and gears. Now that I believe you're well prepared to attack this problem with the knowledge I provided you. This is a nuclear reactor. And using the knowledge I taught you today, we'll be building this in class next week. So come prepared. You know what else really grinds my gears? It's this gear right here.